Is it recording? It's recording. Okay. So let's go to gallery. Okay, so that makes me bigger. Okay, so we had, and this isn't backwards for y'all, right?
No.
Okay, it's totally backwards for me. So, we did this problem last time, right? We were talking about this craziness.
Mm-hmm.
So what did we get for the quarter 30 degrees? It was
60. Oh no, 31.058.
no 5.8. That's what we got,
Right?
right? Is that what we got, Jared?
Yes.
Okay.
That's what I had.
So what I'm thinking here that this, so when I Googled sexagesimal stuff, it literally came up with foreign language stuff. Like, got a whole bunch of like not English documents, like websites and stuff. And I was just like, okay, that's not what I wanted. But then I found a YouTube video that kind of broke it down. So from what I could tell from that, I don't know why all of a sudden it just sent me to like Greek stuff. I didn't understand what was going on, but which makes sense because this was a Greek system. But so this was talking about minutes, I think, and seconds. So you could break this down into, so if we were looking at this answer in the back of the book, right?
Mm-hmm.
So we have 31 degrees. I'm assuming this is 3 minutes and then 20 seconds. So I'm going to see if I do the conversion of this and I get this decimal back. So if I look at 3 minutes, well, for every 1 degree, I have 60 minutes. And then for every 20 seconds, so that'll be 1 minute, and there's 3,600 seconds in a degree. So what happens when I get these two numbers? So 3 divided by 60 is 0.05. That sounds promising. And then 20 divided by 3,600. Oh, this is way off. 0.006. So this is now going to become 31 plus 0.05 plus 0.006, which is 31.056.
Why are we 0.2 off?
No.
0.002.
Did we round at some point when we did this stuff?
Okay.
And this is technically 0.0555555 repeating. So I think there's some rounding errors there.
Okay.
And so we might have had some rounding errors
Somewhere.
in this problem.
Yeah.
But we're only off by 2 thousandths.
Yeah.
So let's see if this, so, and like I said, I am totally guesstimating this is what we are doing. Because this is new to me. So let's try the other one, 15 degrees. So if we looked at chord. Oh, I hung up in my. They told us the answer was
15.66, I think we got.
And we got 15.66.
I think so.
Right, Jared?
Yeah,
Okay.
well, that's what I have.
Okay, so if I take 39 seconds and multiply it by its special one, so this is a form of dimensional analysis. So for every 1 degree, there is 60 minutes. And if I look at the 47 seconds, multiply by its special one, so 39 divided by 60 is 0.65. And then 47 divided by 3600 so that's going to be 15 degrees plus 0.65 degrees plus 0.013 degrees. .663. That one came out nice, right?
Mm-hmm.
So I'm learning something here because we don't do this in grade school stuff at all.
Interesting.
And let's try this last one. So they got this 7, 50, 54, and what did we get? 7 point something?
7.84.
So if I have 50 minutes, for every 1 degree, there's 60 minutes. And then for 54 seconds, for every 1 degree, there are 3,600 seconds. So what we get when we do those numbers? 50 divided by 60. So that's 0.83 and the 3 is repeating, right? And then 54 divided by 3,600. That's 0.015. So then 7 degrees plus 0.833 plus 0.015 degrees, 7.848.
Yeah.
So that's where they're getting those crazy numbers. Figured it out. So they're using 60 stuff. So they're talking about for every 1 degree, there's 1 minute. And then for every minute, there's 60 seconds. So that's where they were getting that stuff. That makes sense now, right?
Mm-hmm.
So they just expected us to know that, I guess. That's what we were doing. Since we do degrees in that way. So cool. Now we know where they're getting these funky numbers. Which that could be beneficial for when y'all do unit conversions, that y'all can show them the weird notation that the Greeks used. So it gives it some historical context. And especially in elementary, we like to do mixed disciplinary stuff. So you can talk about history at the same time you're doing math. And Jared, this is obviously something you could do for unit conversions in high school. So,
Mm-hmm.
so not bad. And I'm happy I learned that because now I know that now. So, yeah. So, we kind of did chapter 5, but we didn't talk about the funky stuff. We just pretty much talked about Ptolemy, but we didn't talk about the weird triangles yet. Because we didn't talk about the Menelaus configuration and then Ptolemy's double Menelaus configuration. And that's talking about curvatures and stuff and how that relates. We also didn't talk about the Romans. So, and Huron's formula. So we need to. Huron is kind of will come up to play in geometry. So I remember talking about that in high school geometry. But no. And Huron's formula is used for approximation of radicals. So. But we didn't get to that. I would like to talk about that, but we're also behind now, so I don't know what y'all want to do.
What are our choices?
Well, because like I was thinking of like typing up my notes that I have on these guys and just giving y'all a fact sheet, and then maybe doing some recordings like this, what those problems solved.
Yeah.
For the stuff that we're a little behind on.
Yeah.
And then we're skipping chapter 6, but I thought it'd be kind of give you, so I might do like, even though it's technically not on the syllabus, but Diophantus is kind of a big deal. And Hypatia is kind of cool because she was the first female mathematician, and that's where they talked about her. So I thought that might be
cool.
Something I could just do like a little mini video on. If y'all were okay with that. If not, I can talk about them.
I'm fine. Whatever's easiest for you, I'm fine with. Honestly.
Because next is the Chinese. And so there we're going to be talking about Pascal's triangle, because technically, even though Pascal did the Pascal triangle and he got credit for it, but there were documentations that the Chinese had it before him. So we were going to talk about that and talk about Pascal's triangle. They also have a lot of stuff on geometry again and solving equations and dealing with the Pythagorean theorem again. The Chinese. So, and then after them is India and Brahmagupta and Al-Khwarizmi, and where we get the development of the word algebra, because that's technically an Arabic word. So if we can maybe jump into that next time.
Yeah.
So if y'all would like, next time we'll talk about the Chinese and just skim through chapter 7. Chapter 7 is actually kind of long. So if maybe, let's try to get through at least 7.3 when y'all are reading this stuff.
Okay.
Because that one is, so that would be their fraction stuff again, roots. They also had like a geometric way of writing roots. And then they had geometry with just calculating areas and volumes. The hypotenuse diagram is kind of interesting and cool. So that might be something to read about. And I think method of double differences, I think we'll talk about that one. That might be a fun problem to talk about. figuring all that stuff out. Because they had like a geometric way of doing that. And it's just algebra though. So yeah. So is that okay? I'm just really having a hard time visualizing because like this class was just us talking about problems and doing problems, and now it's kind of weird.
Mm-hmm.
Which I mean, I guess it could be. There is Faye.
Hi, I'm so sorry. I had it on my calendar, but I didn't see it. I'm sorry.
Okay. I thought maybe you were sick. No, she got it.
No. No, I'm sorry. It was completely my fault.
So we just went over the weird numbers from that last class. Oh, you weren't there then, right? Yeah. So we did the problems, and I think I'm recording this. Am I recording this? Yes, I'm
It
recording
says
this.
you are.
So,
Okay.
and that way you can go back and rewind once.
Sounds good.
Because it's still converting my other class that I just recorded. So.
Okay.
So we did last week. We just did that first homework problem, like calculating the chords, and then we got weird numbers in the back of the book, but we figured it out
Okay.
where the weird numbers came from.
Sounds good.
And so now we were just going over the game plan for this class.
Okay.
So what did we say, Abby?
We're reading through 7.3 for next class,
Okay.
but you said you're gonna write some notes, I think, of the chapters or some of the.
Yeah, so like we didn't go over the like weird triangle stuff for chapter 5, so I was gonna write up some notes on that. Ugh, lost my voice there for a second. And try to do some kind of like mini videos, I guess, of me like what we did here, but like writing them out for y'all, and I'll just post those so that way you're not having to read all of that stuff on your own. And then also we weren't going to talk about Diophantus and Hypatia, but Diophantus is kind of a big deal, but we're skipping that in the syllabus. So I was just going to write up some notes on him, and same thing with Hypatia, since she's like the first female official mathematician.
Mm-hmm.
I thought y'all might care about that. So, and her story's interesting. So I was just going to write up like either some notes on her and like download or maybe make a PowerPoint that you can just skim through that has facts on her. So, and then for Thursday's class, we will start talking about the Chinese. So, and the Chinese are interesting because they had Pascal's triangle before Pascal did, or at least that's what I recall when I took history. And they actually have a picture of it in here somewhere. That's in 7.3. Oh, it's in 7.4. So we're not there yet.
Okay. So we're just reading 7.3 for Thursday?
7.1 through 7.3.
7.1 through 7.3. Okay, awesome.
Yeah. I mean, it's a lot of reading. It's very dense. But
skimming is okay?
Yeah, well, 7.1 is only barely 2 pages.
Okay.
But 7.2 is kind of long. It's 4 pages, and 7.3 is 11 pages.
Okay.
So, but there's a lot of pictures in 7.3. So, I think what we'll do for next time is if y'all can just read through those And then I think what we'll do is I will try to pick some of the problems that we did from that kind of address those. And so that would be we can try to attempt some Chinese symbols. And then use the square root algorithm, cube root algorithm. That was a lot of reading. And maybe we might try the 9 chapters problems, which is one of their books. And see if we can figure those out as a group next time.
Okay.
Does that feel like a good plan?
Sounds like a good plan to me.
So yeah.
Yep.
So if I'm a little behind, I will apologize.
You're
Like
fine.
I said, I am redesigning 6 classes right now.
Yes.
So it's
No worries.
yeah. Because usually when I'm told I'm teaching a class, I have like 2 or 3 weeks to put it together. So yeah, not this time.
It's
And
crazy.
if there's a last minute class, kind of like what y'all's ended up being, because they wouldn't tell me yes or no on y'all for a long time, I at least had a week or 2 to think about it. And
Mhm.
they gave us 2 days. So yeah. So I'm gonna do my best to try to make this at least have stuff for y'all to look at. So.
Okay.
And the game plan is that we meet every Tuesday and Thursday, and I will make Fridays optional for us. So I will
Okay.
be here and available, but if you don't need me, so y'all will have y'all's own technically on special office hours at that time.
Okay.
Does that make sense?
Yeah. So we just like come on here if we need help with something.
Right, and I will just hang out and
Okay.
wait for y'all to show up. And if y'all show up, we'll do stuff, and if not, so.
Okay.
Will this be the same link for each time? Is that how
Yes,
it
I
works?
think so. Yeah.
Okay. Sounds good.
Okay.
So the stuff that is on your paper right now,
Mm-hmm.
that's the stuff we went over on last Thursday, and
Yeah. So we started this stuff like last Tuesday, right? And then we talked about it on Thursday, and then we were doing these problems in class, and we were like, we don't know where these numbers are coming from. And so
that does not look familiar at all.
Huh?
It doesn't look familiar. So
No,
Is
because
that
the answers in the
something
back of the book were just weird, right? It was like, this is what they told us the answer was. And if we use the formula, we got this. And so we're just like, don't know what that means. But I figured it out, I think. It's pretty damn close if it's not it. But
Okay.
because they're writing these answers in this is degrees, minutes, seconds.
Oh, okay. Yep. So is this stuff that's going to be on the test or not?
Yes, this type of problem will be.
Okay. So, and you were discussing this before I came on, so
Right.
I can go back.
Yeah.
Look at that. Okay. Sounds good.
So
Sounds good. Thank you.
yep. Oh, we have 10 minutes. It's telling me we're running out of time. So, but yeah, I think we have a plan. Do we have a plan?
I think it's a good plan.
Okay.
Yep.
So,
Sounds good to me.
oh yay, my class finally finished converting, so now I can put that up. It took 30 minutes for these recordings to convert into MP4s. So,
Wow.
how much space does this take up? Properties. Just curious. Oh, not bad. Only 393 megabytes. So I think
Besides this degrees and minutes and seconds thing, is there anything else that I missed on Thursday? I'm having
we
trouble
just did. What did we do?
because I was gone at my subbing thing on Thursday.
Right.
And then we didn't meet Friday, so.
So we did Ptolemy's chord calculation stuff, and we attempted to figure, and we did figure out the double angle stuff, right? Or half angle stuff, right? But we couldn't figure out it to the proof. And we got halfway through it and then kind of were like, I don't know. Because they made a big jump in the proof and we couldn't figure out how they made that jump.
Okay.
So.
And then we had those 2 calculations you gave us, didn't you? That I don't know if Faith got.
So we had
Or
the
those
chord
uploads.
stuff, and then we just rewrote.
It was like those chord equations.
Right. Oh, that was one of the homework problems too, right? And we had.
Yeah, it's number 1.
That was number 1, and then number 2, right? We also did number 2.
I think we talked about it. I don't remember what it said.
Because it wanted us to find 120, 150, 165, 72 and a half using his chord formula for 180 minus alpha.
Yeah. Yeah, we did that.
And I didn't give y'all number 4, or did I give y'all number 4?
I don't know if we got it. We didn't do it in class, I know.
Okay. I might do a write-up on that. Let me make a note to myself that I'm going to do this stuff. So we did that one. So I'm going to try to do 2 and 4 for y'all. I'm going to attempt to try to get that proof down to figure out where they made this giant leap of those triangles being congruent. And then I also want to do this. So I'm going to make a video on that. And I'm going to see if I can make the video on this weird picture. So yeah.
So are you going to be sharing these videos with us during class time, during Zoom, or just putting them up on Moodle? And we can watch?
I think I'll just put them up on Moodle, and then during this class time, we'll go over some of the stuff and questions that y'all have on some of these things.
Sounds good. Just wanted to make sure.
Yeah. And I'm gonna do some stuff on Diophantus. I need to start making a list now. This is getting too big to smart things. Where's my tabs? Oh, this thing fell apart. My little booklet of post-it notes and tabs is falling apart on me.
Oh.
It's too humid in here. The glue on this little book holding it together is peeling.
Thank you so much for texting me, Abby. I came back into the room and I looked at my phone and I was like, oh no!
I had to get a text from Jared too. I was like trying. I couldn't figure it out for a little while. So you're okay.
Well, I was gonna say, it was gonna be awkward if it was just me and Jared.
Yeah. Without his picture.
Yeah.
He doesn't want us to see him. I guess he didn't want to get any comments about his hair.
No,
Really rough looking.
I just woke up, so.
It asked me if I wanted to share my picture, and I was like, yeah, I guess so. Like,
Oh, I don't want to show y'all what I'm looking like because I'm still in my pajamas. So
I'm looking a little frumpy, but at least I'm representing, so we're
yeah,
good.
Yes.
I'm wearing my Reptar t-shirt, so, and sweatpants. So yeah. So yeah. All right. Well, what do y'all think? Y'all good?
Great.
I think so.
Okay. All right. Well, there's a plan.
Yes.
Let's hope it follows through. And of course, email me if y'all have questions or concerns and whatnot. And I guess I will see you two guys later this afternoon. I'm
Yes.
going to attempt to show like this stuff on the screen and see if y'all can do some of these problems with me
Okay.
and see how that goes. Because I was going to plan a teaching activity for y'all, like I said last week when I saw y'all on Tuesday. But then, you know, we had the apocalypse, so.
Yes.
So. But yeah, so
So we're
just let me know
Sorry.
and keep in touch. And I will also have a link to office hours on here for regular office hours time. Also about turning in work and stuff, I'll put Turnitin assignments on Moodle for y'all and try to get that set up so that way, and like quizzes and exams will probably, the next exam will probably be a take home, if I think it's during this time, right? And we'll talk about y'all's projects on our optional Friday meeting, so to get more direction on where we're going with that.
Yeah.
So
Okay.
yeah,
So we're just reading 7:1 through 7:3, and there's not any homework problems, right?
no, because we'll do
Okay.
those together once I
Okay.
figure out what those are.
Just wanted to make sure. Okay, thanks.
Yeah, so just read those and try to take some notes and try to digest, because there's a lot going on there, especially in the 7.3 section. So yeah, and I will convert this thing and upload it onto Moodle for y'all too. So yeah.
Okay.
All right, so we have 1 minute and 34 seconds left, according to my countdown time up here. So
Yeah, I can see it too.
alrighty. Well, if
All right.
not, then I will see you guys on Thursday, and y'all too. I'll see y'all later.
All right.
Okay.
Bye.
All right. Bye.
Bye.
Bye. Thank
Bye.
you.